like to get out of it. Very happy to learn and then also, yeah, fine tune it to questions coming up.
Good
We'll
talk.
talk about fine tuning a bit later in this webinar.
And we'll also be checking for questions on our streaming platforms on LinkedIn and YouTube, so feel free to drop them there as well. Jorg, what are you most excited to talk about when it comes to domain-centric Gen AI?
I think what I'm in general excited about this topic, it feels like a very old topic, right? I feel like domain centric. It was came like 2003, I think was that book, and I'm amazed that kind of those concepts they still apply to very modern tools. So I think with a lot of things in the Gen AI realm, where I feel like if we remember lessons we have sometimes painfully learned in the past and can apply them here, this is always good. Because it's not something completely new, right? But it's something where we can apply lessons to new concepts such as Gen AI.
What's your what's not your least favorite part of working with RAG apps and agents, but the part you most dread?
Uh, I mean, the exciting part, like wearing my research hat or kind of wearing my product hat. And wearing my product hat, it comes down to security, scale, maintaining precision, or like high quality answers when scaling up the system. That's my product hat. Um, my kind of more like research hat, if I want to be excited about what I'm actually then curious about is figuring out how can we provide the most relevant dynamic context when things come up.
Nice. Me too. Um, awesome. We're getting more and more folks coming in. Uh, would love to hear where people are calling in from. If you can drop your location in the chat, that would be awesome. Jorg and I are both in San Francisco, which it's Dreamforce, so there's a lot going on. And
Apologies.
Jorg, I think we can get started.
Yeah.
Got a good set of folks here. So I will have you take it away.
Yeah. Thank you so much. And thank you so much for joining. This is a really interesting topic for me personally as well. I mentioned that just a bit earlier when we were chatting. I'm always amazed how we can apply lessons we've painfully learned in the past, potentially other domains, to the new concept of Gen AI and hence really make it scalable. So today we'll be talking about domain-centric Gen AI and in particular, how can we serve smart context for Gen AI applications, agents, RAG applications, etc., without overloading them, and how this can be enabled by autonomous data products. So if I'm seeing people adopt agents, Gen AI, I'm typically seeing like two gaps or two like blocking stones. I think the first one is always what I would call the data gap. So the data gap is like, how can I connect my RAG applications, my chatbot, my agents to data? And at first there's no connectivity. So how can I get my potentially sensitive company data in there. And we actually talked about that earlier this year. So if you want to watch or read the article about it, this was about how can you cross that chasm in between AI applications and making data accessible in a safe fashion. I think then typically the second phase is actually the often the opposite of that. And I would call that like context overload. And this is basically when like all those building blocks, all kinds of data, um, we expose them to our agents, we expose them to our RAG applications, and it's basically just too much, right? Imagine you just have like a single MCP endpoint in front of your Snowflake doing text to SQL. Imagine you're exposing your entire data lake to those agents, and that's basically just overloading them with too much unspecific context. And I mean, typical signs of that is you'll see very high token cost because you're trying to process a lot of data. And actually, again, we come back to that problem of hallucination or unspecific calling because it is just too much context for the LLM to choose what is relevant here to use. And this is what we'll be focusing on here today. Maybe just who I am. I'm Jörg. I'm head of engineering here at Nextdata. And my background is actually building a lot of machine learning, a lot of data infrastructure, and also building database systems. So I'm pretty happy here right now because I feel like I can combine those two passions, systems engineering and building out data platforms, data and machine learning platforms, enabling people to use that. So, let us dissect a bit the title and try to build a foundation of what we want to cover today. So, kind of domain-driven design came around. I think the seminal book was in 2003, and it was about how can we actually turn kind of the perspective on software engineering around. Instead of first focus on technology and then business domains, do it the other way around. Try to focus on the business domains who need to provide value and have that to drive software development. So from language boundaries over interface and kind of have derive as a term is their bounded context. Around each kind of domain knowledge and value. And I think that already has kind of served as a foundation also for microservice movement in the past 15 years. And now we'll see how we can also apply that over to data. And here, if you haven't read that, or there are also like multiple kind of summary or updated versions of that, I would really highly recommend reading Domain-Driven Design because I think it really tackles this domain thinking about the business first, what are we trying to achieve, instead of starting from like a technology perspective, kind of what is possible out there. Um, Second, kind of like if you remember the title slide, second kind of item which might need some explanation would be data products. And interestingly, data mesh and data products, they were also heavily inspired by domain design thinking. And so here, for example, down here, if we see like the four foundational pillars of data mesh, they are data distributed domain-driven architecture, self-serve platform design, and product syncing. So to maybe make that concrete, very similar as we talked about earlier, instead of designing one or instead of starting by designing like one big data lake from a technology perspective, you try to think about the different domains. So here is one example from the initial blog post, also linked down here. We have artist domains who are very much focused on what is centered around that artist. We have the podcast domain, user domain, and the media and audio streams, right? So what if we would build kind of like a streaming application for music, what are the different business domain we need and what are kind of like the data and data interactions we need for them. I don't necessarily want to go into much more detail on data mesh because I think we have a lot on the website on kind of like the core principles, but maybe just just as a foundation, we'll dive deeper into data products in a bit and how they're applicable, but maybe just to have like a common ground if it comes to data mesh and how it relates also to domain-driven design. Data products, or in particular autonomous data products. Since the book was released, I think there have been really a number of people and a number of different interpretations of what data products can be, from very static assets where it mostly focuses around discovery, to yeah, just a very broad range of different interpretations of data products. The notion we have here, and the notion we have by having the author of that book founding Nextdata as a company, is what we call autonomous data products. So I think the core difference is it is not just a static asset which gives you visibility to data. It's a running process with a life cycle of discovering potentially new data, sensing inputs here on the left, then checking the data, checking expectations, computational policies, orchestrating the transform, validating the outcome, and then promoting it, aka making it accessible to downstream consumers. May it be another data product, may it be a dashboard or something for what someone else has built. So um, each autonomous data product is actually a running process with also its own API. So if I want to share a data product, for example, with Shab, with some data, including everything I need to access that data set, from metadata over APIs to request access to that data if I don't already have it. There's a URL representing each data product, and I can share that. There's an API behind it. So here we have a short screenshot of the API spec for a particular data product. And then from there, I can basically go and interact with the data, with the metadata out there, yeah, start working with data. And this is actually true for both us as humans. If I'm saying I'm sending that over to Shab for because she wants, for example, to look at who were all the people who have visited this webinar, what were all the questions in this webinar. That could be one particular data product, but it is also true for more autonomous consumption. So, for example, for agents or LLMs trying to interact with that particular data set. So for example, like here, our webinar data. To maybe make that a bit more concrete, let us look at a particular data product in context around. So here we're trying to build a customer feedback data product. So that customer feedback data product, it has two kinds of inputs. One is very structured data. So for example, our Amazon reviews, which could be just stored in, for example, a Snowflake table. Of course, we always know we're going to get certain fields. Some of them might be null or non-existent, but we have a very structured input of our reviews for our products. On the other hand, there can be also more unstructured data. So for example, point of sales customer feedback. Imagine you're going in a store, you can fill out like a small form, and by the end of the week, that actually gets scanned and sent over to be analyzed. The first thing our customer feedback data product will do when consuming the data, it will try to sense, is there new data available? So I've seen a lot of jobs, especially Spark jobs, which are just scheduled to, for example, run on like an hourly basis, but there might not be new data available, or there might also not be like the need for like new output available. So in particular, in this example, we have very different uh, rates of change. So the Amazon reviews, they might come in on like a minute basis or even faster. The point of sales, scanned PDFs we get from each store, they're going to come in maybe at the end of the day or even just once per week, depending on the individual store. So we have very different rates of change. And so we have to decide, when do we want to update our outputs? When do we want to update what our consumers are going to see? Because probably it doesn't make sense to update for each individual Amazon review. So this is kind of the first part, kind of the sensing inputs and deciding when does it actually make sense to update to run. Second part is then checking the input quality. So do we have all the fields present? Is data freshness guaranteed? So basically, really applying data quality rules. And I think there's a contrast again is that a autonomous data product, it is a running process, right? So this is happening within the process. It is nothing which has happened like post fact where, oh, you get a message, oh, my data is broken. It is something which is happening upfront before the data is processed. And we'll see the second part on the promise side later. When that is all checked, we would actually run our transform or run the actual compute. And this is a data product you can imagine just as a logical layer on top. So it doesn't replace your Spark, it doesn't replace your Databricks, it doesn't replace necessarily a Snowflake transform, but it actually can interface with that. So it is a layer on top. The data will still remain in that underlying infrastructure and will also be computed there. But the data product is keeping a global coherent view on the metadata, when it should trigger, and also has it, for example, run successful. Once it has the actual compute has completed, we're doing the same we have done on the input side, but now on the output side, we are checking our data quality rules. And again, this is happening within that life cycle of the data product, which means you don't just learn about, oh, the output was bad, but there are already consumers consuming it, but it happens before consumers get access to that data. Once all those data quality checks have passed, we make data available to consumers in a step which we typically call promotion. We are promoting that data to be consumed by downstream consumers. And this is where we actually come up on different consumers. And I think also a very important feature, especially if we talk about autonomous consumption, if we talk about agents, if we talk about rack access to the output of the data product, and that is the multimodal aspect, the multimodal output of a data product. So the core concept, which we'll also see in a bit later in the live demo of that data product is around like a semantic model we are offering. But that semantic model, which in our case is a customer feedback data, can be served in different physical representations to make it best consumable by a particular consumer. So, for example, if we are building a RAG application, a chatbot, probably some kind of like embeddings, which we can see here are most suitable for consumption. If we are more catering towards the data scientist who wants to further analyze that data, some SQL-like representation, for example, in Snowflake, and if we are rather trying to actually fine-tune models or building other models out there, some kind of like more document or more file-based format is going to be very suitable. One problem with this kind of multimodal aspect of data I've often encountered in my past, at least, is the coherence between those different models. So, for example, if you're writing your vector embeddings if you're creating them with one compute pipeline, you're computing your SQL output with another pipeline, they might be out of sync. There just needs to be like one failure in one pipeline, or just even them having different runtimes. But if you're consuming then output from both of them together, because you, for example, need additional metadata from the SQL store in addition to the embeddings, which you've used to find like the best nearest neighbors around, and those are out of sync, you'll end up in problems, and debugging these will get really hard. By having all of that orchestrated by that single data product lifecycle, we can ensure, or the data product actually can ensure that all those outputs are always out in sync. That actually brings us to like a last and like I think really interesting last kind of like output mode. And that is nowadays we often talk MCP, we often talk kind of like agent access or API-based access. And a data product can actually define its own tools as well. So it can say, I'm offering these particular tools. If I'm thinking about it from like a domain-driven design perspective, a data product is actually saying, hey, LLM or hey, agent consumer, those are the questions I can answer really well by offering these as a tool to you, right? And there we already seeing like one aspect of making it really specific by not. I'm seeing like many MCP endpoints being text to SQL, for example, which has a value by itself, but it's going to expose a very broad range of data. But by encouraging people to write and encouraging the domain team owning that data product to write a very specific tools endpoint with the questions, with the operations that data product supports really well, it will make it much easier for any Gen AI based application to access that for the use is intended for, right? So rather than offering a very broad, I can do anything by text to SQL, offering very specific tools is going to be super helpful. All right. So I think this is kind of like wrapping up around the data product. Again, there are like way more focus on that and more deep dives available either in the book, many blogs are around, or also just feel free to visit any of the other webinars we are hosting at Nextdata. And by now, we hopefully we have all the foundations for talking about what we actually mean by domain-centric Gen AI. I think we already dove a little bit into that. Is the basic thing we want to have is how can we avoid overloading the LLM? How can we avoid overloading the agent with too much unspecific data, which might not be relevant for a particular task? And so for that, to really make it like specific for a domain, or how I'm thinking about is what are the specific aspects like we would offer in one particular domain, for example, finance domain versus marketing domain. I'm seeing like three main pillars here. And I think the first one is like what context that domain is offering. Like a finance domain is going to offer very different data, also with different access rules, with different governance rules, how I can access that data, than, for example, the product domain or the marketing domain. So by making the context for an LLM specific, not expose like all my company information or not expose my entire data lake, but expose specific information based on those domains. I think this is kind of the pillar like domain-driven context. What is the context we make available down there? For example, for a RAG-based application someone is building. Second part is then domain-aware tools and resources. I probably like during this talk, I'll always use tools as kind of like a shortcut instead of saying like tools and resources. But basically, we're talking about MCP tools and resources we could make available. And here, again, exposing too many tools. think this is a trend right now. If you ask me personally, I think there are some more steps in MCP towards like MCP 2.0, but I think everyone is kind of like building tools these days, or at least experimenting with tools. So we'll end up with like a very large number of tools out there, and I think the protocol by itself has a limit of tools, but there are experiments where basically we're seeing if we are exposing too many tools to a rack. We'll end up with fairly bad results out there. Because it gets hard for the LLM to choose which tool to use, which tool to call for that particular problem. So kind of like fewer but smarter picks will result in better, more specific results and also lower cost. And we'll dive deeper into that in just a second. The last part out there is domain-specific LLMs. So, in terms of like LLMs, we might want to use both from like foundational ones. Am I using Gemini? Am I using some OpenAI model out there? Those vary very much in performance for different tasks. I think there are a number of startups kind of developing routers to kind of like route to the best LLM, and I think if we just think about it from a domain specific perspective, the finance domain is going to need a different base LLM, or at least probably a different fine-tuned LLM with potentially different system prompts out there. And so because we have such different requirements, I'm kind of like foreseeing a future where each domain is going to have very specific access to LLMs, and probably this is also going to be safeguarded. Like the finance LLM, it might have specific prompts which have semi-sensitive data, so we might not want to expose or give access to that LLM to everyone else out there. So it's going to be a domain-scoped resource to use. For the remainder of the talk, we'll skip a little bit over this topic and leave it out because probably it deserves like a webinar by itself. And secondly, we want to focus a little bit more on how do we make data accessible and how do we avoid the data overload here. But as mentioned, I feel this is a very interesting topic as well and very relevant topic as well going forward. So, let us dive deeper into the first topic, domain-driven context and data. So how can we avoid exactly this overload we were talking about when we are building a chatbot, when we are building an agent? And kind of how I'm thinking about it is, I mean, we do that naturally in the surrounding world as well, right? So if we're having like a legal assistant to find like a particular clause or like work on a particular contract, we're going to make that contract plus all the associated context available. But we're not going to give her access to vacation photos, Slack threads, or like unrelated PDFs out there, because that would actually distract her as a person and working on that task. This is actually even more true if we're talking about autonomous consumers, agents, etc. Of course, they'll just happily take all the data we have out there. And so I think the key here is if we think about how can we provide the relevant context to a particular task at hand, for example, by considering the particular domains, right? They provide a natural boundary of what the context needs to be available, for example, marketing versus finance domain context for a particular task. And the results we have seen, there's also like in the notes, there are linked several other blog posts and benchmarks around that is it will lead to better relevance of our answers. It will lead to fewer hallucinations. Hallucinations usually come from if we have unspecific data available and the LLM tries to extrapolate that data to parts where it doesn't really apply. And also what you'll see, like bottom line, what you're spending is you'll see just a lower token count, aka lower cost. So how does that apply to data products? How can we use data products or data mesh to apply that? And there is a pattern mesh rack. We had an own webinar about that. But the core idea is we are actually selecting the relevant data products first, right? So when we have a particular question, in this case to our chatbot, how does product feedback impact sales? We can first check on the metadata of what data is available, what data products are available, and then we're only going to connect and grab the output of the embeddings associated with those data products out there. So the rest, we're just going to not actually consider as context. So by kind of having this two-step approach, we can already like fine-tune those results quite a bit and therefore achieve more relevant context for our query. As mentioned, we have, I think it's already a while ago, but material still feels fairly relevant. We had that blog post and also webinar around Meshrack. So if you're interested in diving into more details around that, I can just highly recommend that. Then let's switch over to domain-aware tools. The same applies here. As we said, like if we are offering too many tools out there, it feels like a candy store, right? And the LLM doesn't really know what to choose. It'll try to poke at everything, which first of all leads to like longer run times, again, less specific results, and then also a lot of like external calls out there, which are associated with tokens being spent on that, but often those external calls, they will also cost us resources in that sense that A, latency, which is going to slow down my query. B, it might actually cost money as well to request certain tools from an external source. So this is where I think a pattern is becoming not just with data mesh or data products very prevalent, which is called progressive tool discovery. And this basically means we're not offering all tools in the beginning. We might have hundreds or even thousands of different tools out there, but when an LLM connects, we'll only offer like a small part to it. And this is, for example, here in this would be a concrete example how that would work with an autonomous data product. So the agent lifecycle we're having, it would start out by intent discovery. So we are having a prompt. In our case, this might be we want to find out like some sales data. How does customer feedback impact sales? So we first of all we're going to have that prompt available. And when we have in this first phase, the only tool we have access to is actually a tool called Discover Other Tools. I mean, the tool itself might have different names, but kind of the main function is we want to discover other tools being available out there. And this is the only tool we have access to at that instance. So we're going to call it with that particular context available. And then in the background, the gateway, or in our case, a system data product, is going to check what metadata is available, what data products are available for that, what data products make sense to that. And then with that, we can actually make more tools available. So for example, here in this case, we can, in addition to the discovery tool we had available all the time, we get access to like our customer feedback, get customer feedback for a particular channel tool. And then once we have access to that tool, we basically going to continue with like any other tool invocation. We're going to call that. We're going to get the output of it, and then we can make like the LLM can actually go and make its decision out there, and life cycle starts over again. And the same, we talked a little bit about it with like prompts and kind of like from a chatbot perspective, but the same is true for any agent out there, right? For any agent, it might have a different task, it might delegate different tasks to others, but the same is actually true for any autonomous consumption and making tools available progressively and specific to a particular task. Right. Let's quickly maybe jump over and see how that would look like in a real world scenario. So here, this is kind of like the zoomed out Nextdata UI. So I really zoomed out as much as I could on this, so we can see the different domains. So each of those blobs is representing a particular domain, and could be even like a subdomain. So for example, here retail is kind of like the high level domain, and it has subdomains such as sales, wholesales, or product. And already at this high level, we can see that there are certain connections in between where how domains depend on each other. If we start zooming in, we start seeing the actual data products within those domains. And so each of those hexagons is representing one data product. And now we can also see the lineage way more closely. So either, for example, we can see like input coming from another data product here. Sales influence insights is consuming from online sales. And then, for example, it also online sales might consume from like a raw data source such as ADLS out here. So we can also see the connections to the underlying infrastructure. If we go into some more detail into this data product, The first thing we're seeing is actually the semantic data models in this case, which are being made available. So here we can see four models are being made accessible, and if I'm now wearing my hat, I want to figure out, can I use this? So I'm now a manual user trying to inspect, should I build a dashboard based on this data product? This usually is really helpful because it gives me like an insight into what I can see. I can also get discovery data about this data product, and I can also see how it semantically relates to certain concepts. So for example, here, product ID, I can see, oh, this is actually the same attributes, the same concept as another data product. So typically, if you want, this translates to also like foreign keys or like established concept, established vocabulary within a particular domain or even within a particular company. Um, N- Next thing, which I always find I would look at is like, hey, this is actually a running process. So right now I can see running process 100%. It was last updated 5 minutes ago. So that was like the last output we have produced out here. And we can also see the various compute services being used by that. I always feel this is a bit contrived in an example, so probably uh, it is rare we'll see that many different compute and storage services being used by one data product. But keep in mind, this is in our demo environment out here. Next, if we are scrolling down, we can see the API functions being offered by it, right? So this is basically the questions, as we said earlier, this data product can answer really well. So for example, here we can get sales news correlations, how are sales correlated with social media news, which might be out there, and also get total sold by channel. So those are kind of like the two kind of like questions the data product developer knows this data product can answer really well. This was kind of like probably the things I would first look as a consumer of this data product. Next, if I either want to dig deeper or if I'm actually the data product developer, what I of course care about, where is the data coming from? So here we see on the input side, we have a mixed set of inputs. We have inputs from different APIs. So those are our API input. For example, the news API or the Twitter API. So we can get like our news data, was that product mentioned out there in the news. And we also have input from other data products. So online sales, store sales, and wholesale sales. So we can aggregate and then correlate the news mentions against the actual sales across those different channels. This is on the input side. Jumping over to the output side, we talked about earlier those data products that can make data available in different physical representations for different consumers. So, for example, here we have our BI output in Snowflake. We have a more table iceberg output onto S3, and then we have our vector embeddings stored in Pinecone out here. So I, as a consumer, I can choose what is the best format for me to access those data models we've just seen. Last, the API functions we have here, we make them available via the API output. And in this case, this is an MCP API output. So that means I could directly connect also my agent or a particular tool against this MCP API output. Of course, I'm also worried about what is the safety on this? Like, what is the actual data I'm consuming? What can I rely on? And as a consumer, I probably would look here at the promise side. So those are like the data quality rules. This data product is promising to me, and this is what I can rely on if I'm actually consuming it, because it's checked like within that process of that data product. There's a slide concept, and I just want to briefly touch up on it, which are called policies. We had an own webinar about that. So maybe Shab, if you could just, that's another interesting link to drop in there. And those are policies which are applicable to that, right? We're talking here about the promises a data product is making, but this is what I decide as a data product developer. there's still certain rules either within a domain or even across that entire company. For example, we cannot expose PII. So there are certain policies a data product needs to adhere to because otherwise the output will not be accessible. And so, for example, here it's a data compliance rule that we are not exposing any PII. So this is kind of like a globally enforced standard for my data product I have to adhere to. All right. Enough about the data product itself. I can also share that with someone, but let us take a look at how this can actually get accessed. And I've here my Cloud Code connected to it. And Cloud Code in this case, it is connected to my entire mesh, right? So I'm not connected to a particular data product, which is another option if I really know I only want to connect against that particular one. But I'm actually connected against that entire mesh. So in this case, I can't even ask like what are all tools available to you, and I hope available. Live demos and live typing are always interesting, but what is happening here in this case? Let's maybe quickly zoom out here again. We're gonna take a look at this entire mesh because we now particularly asked for like all tools being available out there, and here we get the different tools we would have available. Like in the bank and in financial analysis, we have like get banks, get deposit rates, and interestingly, Claude is actually taking the outcome and is grouping it like naturally into our domains we have out here. So I find that quite interesting. In the sales and analytics domain, which is where we were just looking before, we have these tools available. And then on the data product and discovery management, and I think this is kind of like these are the high level mesh level APIs. Uh, I also have certain tools available. And I think those are probably the most interesting ones, because those are the ones which, if I'm asking a question, which we can do in just a second, those are kind of like the only ones I have available. So it's basically comes down to I want to see all data products to be able to identify that. And then I'm gonna either automatically or if I really want to, I can also do it manually, set filters for particular tools. So as said, like our question in this case, like what are all tools available? But if we ask what tools are available for sales and feedback related questions, we hopefully are going to get a sub-filtered result. So in this case, these would be the tools we would make accessible to the agent at that instance, right? So the agent, or in this case, our chat tool, Claude, it only will see those particular tools, so it doesn't get confused by like all those banking tools, which probably, if we are talking about customer satisfaction and product feedback, are irrelevant to us right now. All right, with that, let us jump back here and just quickly summarize. So I think the core concepts of domain-centric AI, Gen AI, or in general, how can you build successful and scalable Gen AI systems? I think it comes down to multiple aspects. Have a standard interface. In our case, those are data products, but whatever you're building, I would highly recommend to have a standard interface to your data. We have also often seen it's really hard to switch from like a more demo environment, right, where you have people going in and building a prototype against DuckDB, and then you need to switch that over to, for example, Snowflake out there for the production data. It is really hard, and this is where at least many, if not most, of the AI projects I've seen fail actually struggle at this bridge from like we've built a prototype, but we can't turn it over to a production use case because we are missing those standards and we would have to rewrite everything from scratch. Then it comes down to specificity, and that was I think the main focus on the last 30 minutes is how can we make relevant data, relevant tools, relevant resources available to the LLM, to the agent. And then the last pillar, I think, is really safety. How can we make sure this is in a safe fashion and we are not exposing any data out there which might not be relevant, which might not be desired to be accessed. For example, we've seen that PII example, like PII example, for example, should never be accessible through a vector output. That could be like one of the rules I have as my company. So, with that, thank you very much for listening. If you have questions, I'm seeing like some QAs here. I think we have some time left for those. Otherwise, also highly recommend a website. I think we already had like some links if it comes to like previous blog post webinars on particular deep dives. But otherwise, feel free to keep the questions coming in here. The first questions. Are you seeing any movement towards improved industry standards around semantics? Uh, I fully agree with you. I think I also would love to see more standards. Right now, we're seeing a number of standards out there, and this is where currently we as Nextdata, we take the stance that we can plug in into different standards, basically have connectors to different standards we can connect to. But 100% aligned with you. I wish there would be a single standard because I think it would also benefit the overall ecosystem around. Shab, was there any other questions also on the other channels? Sorry, I probably can't see them on my screen here.
Yeah, yeah. So we had some questions that were sent
Mhm.
in, and one of them, I'm paraphrasing it, but it was around how you can measure the quality of domain separation.
Mhm. Um, I think the you you can very nicely see that throughout the access patterns, right? I think first of all, the separation it comes down to I mean, if you measure it from like a day-to-day interaction, are what people outside of that core business domain you have, right? The business reality you have is you have some domain team working on a particular topics. And then how often do you need to interact with other domains, with other data products? And I think this is where data products really give you like a measurable output because you can see, A, how often did you need to make changes across domain boundaries for another data product out there? How often did you need to access data products from another domain? So basically, you get the entire like change and access patterns transparently, and you can review that. And I think that gives you a nice measure for like domain separations. Um, I'm seeing like one other
We have,
question coming
yeah,
in
we have a
here.
few more.
Go ahead. Hmm?
Yeah, so the next one's from Joe. Do you think domain teams should both build the data products and agents, or should agents be done by a separate team?
Um, Let me let's start by like agents, which are kind of like um, providing a value. I think they should be built within those domain teams. Probably it's going to be expertise you'll pull in, but they should be at least built in very close association with the domain teams. Because as we said earlier, I think they should be aligned with the value provided by them and also with the context being provided there. If we need to build like cross-domain agents, there's also a use case for that. But then we need to be more careful what do we actually feed to them. I think the other maybe sub aspect of that is who should build those MCP endpoints, and there I would definitely see that should be aligned with the data products. It can be at different levels, right? Like building it versus specifying it, but at least saying what we saw and with like the API functions. These are the questions a data product can answer well. This should happen like within either the data product developer or at least like the data product owner should have impact on the input on that. Um, I'm seeing like one more question down here. Do ontologies play a part? Uh, I think this is if you saw my slide earlier, I have like a large background on like graphs, etc. Uh, yes, I think ontologies play a part, especially if it comes up building either domain specific terms and vocabulary and also enforcing more global concepts. I just believe this is going to be like at least an own blog post by itself, or also like an own webinar by itself. But I think it's a really interesting topic, which deserves more than just like a 30-second answer here. But please feel free to ping me on either medium. I'm happy to discuss it in more detail.
Jörg, we have another question. How is data trust established, identifying sensitive data, etc.?
Hmm? Um, so I think there are two parts to that. I think the first part is in potentially as early as like a modeling phase, identify the sensitive data aspect, and then also establish rules around that. I think the data trust is more than just the sensitive data, etc. I think the data trust, and maybe let me switch back here for a second to a particular data product, say sales. I think if I'm a consumer, here, let's go to the data product we had earlier. There's more on just um, whether I trust this data product or not. I think the second part of that question was like sensitive data. This is typically more a question governance people are going to ask, like, oh, is my sensitive data actually safe? I, as a consumer coming to a data product, I probably care more about other aspects. So, for example, like how often is it running? Now we're seeing it has been updated like a minute ago. Um, I would care about like what is its compliance to the promises? What is the compliance to the expectations? Who are the other users of that? Is my data product accessed fairly frequently, or has it been only accessed like once in the last like 24 months, for example? Then I probably would trust it less. And then the second thing I, as a consumer, would look at, I would have a deep dive onto like the promises, because this is exactly for like trust. This is what the data product is promising me I can rely on. I hope it
Awesome.
was okay. I tried to pick that apart because I think it's like it's a trust in the data product from like two different personas. Um, but feel free to ask otherwise follow-up questions.
Yeah, we
Yeah.
have another question. How are we going to handle the access of users across domain-specific data?
Um, yeah, I've found it here as well. Um, what we can do is I think we as Nextdata, and I've seen it like I think it's fairly common. We distinguish between two levels of access to data. One is the metadata itself. So, for example, what we're seeing here, based on my permissions, I might not even be able to see that here. I mean, even the description, for example, it might reveal sensitive data. Imagine HR has a data product for like performance data or something similar. So I think even like that metadata about data can be sensitive by itself. So that's kind of like the first level we can give access to. Um, and then the second part, and again, this is pluggable. This would be the access to the underlying data. So here, for example, in this case, I can hit request access. It's going to check the policies in the background, which is why it takes a bit, and I will get like a temporary access to that data resource. And I mean, this is now showing it on the UI. Typically, this is going to happen like through some kind of like, for example, Power BI connector, which is going to request that. It's going to identify these are the data program I want to access, and then I can request them. And this is one of those pluggable components we can work with. So I feel this way to data access is very specific to each organization. So in this case, it relies on like basic policies, and then we're using HashiCorp Vault to create temporary credentials. In many other organizations, this might even raise an asynchronous process such as a Jira ticket. If someone approves, you get access to that. So this is very much dependent on the company-specific rules or the organization-specific rules. I see. Otherwise, the next question here is: does data get replicated if it gets mapped to different data product? Um, if it gets, I think you're talking about, for example, here's a consumption, right? It doesn't get replicated. As mentioned, the data product, imagine it as being a logical representation on top. So the data is remaining in the underlying S3, ADLS, etc. And then first, when the transformation kicks off, it's going to access these underlying storages. Um, having having that said, each data product, if it comes to the output side, each data product is kind of controlling its own output. So the table representing, for example, here's a snowflake table. This is going to be owned by the data product, and there's no one else writing to it. So kind of like from a producer point of view. Um, uh, Shab, I just keep reading. I hope I'm going
Yeah,
in order. If I'm skipping any, please just call me out.
yeah, go ahead.
Yeah. Yeah, I think the next one here I'm seeing is, are you seeing situations where the mesh becomes a dumping ground with data products that do not provide value, non-trustworthy, etc.? I think uh, I think we are aware of that risk, but I think exactly the visibility of like mesh level visibility, it kind of gives you tools to prevent that. So I've actually seen that like very often, like outside of data meshes, where there are hundreds of Databricks jobs running every hour. But no one actually knows what they're used for. No one is actually accessing them. And similar with just dumped data somewhere. People don't know what they are being used for and what the exact meaning is of that. So we have like kind of a view. Again, it's a slightly different perspective for like what we call insights. So if I'm the platform owner and I want to know, are there any data products which don't provide value because they don't get access, I can go here. I can see like the usage. I can see which ones are not being used, but I can also see which ones are being used, right? So I can see like what is the value of each data product, and then I can basically prevent exactly this. I think how did you call it nicely? Like becoming like a dumping ground out there, um, because I have the insights to prevent that. And I think the nice aspect of it is this is actually across technologies, right? Again, going back to what we said like about the core idea of domain-driven design, we try to go away from like technology first and actually try to take like a business domain perspective first. And I think this is very similar. Like we can actually see that across different technologies, right? If you would imagine that trying to answer that question before, what transformations, what jobs, what storage is not really being used. I would have to go into my Snowflake, look at usage statistics. I would have to go into my Databricks, look at usage statistics, etc., etc. Because I don't have like that global view of what data actually matters. So again, kind of like just taking not a technology first perspective, but taking like a data or value domain value perspective first.
So the next question, what's the decomposition methodology for data products, event storing equivalent? Any resource recommendations?
Data. Uh, I uh, I
We can
interpret
come
that.
back to that. Yeah, because we only have a
Yeah,
minute.
yeah,
So we can
yeah.
follow up with Indranil.
Mm,
Another, do
mm.
the insights only show usage happening through Nextdata? Would it show usage data if someone consumes directly from Snowflake as well?
Yeah. Uh, if I mean the consumption later is going to happen like directly in Snowflake, right? Let's take the example someone is building a dashboard. that dashboard, like through a Power BI connector or even like manually, if you wanted to, how the access would ideally happen is the Power BI is connecting to the Mesh APIs. It's going to ask like what data products are useful for this task. It's going to request access to the data products, gets a temporary token. And by this temporary token, it's then going to access the underlying storage directly, right? So the data isn't flowing through Nextdata itself, but by having this access request, we actually can associate the underlying access to data, even if it's what we call like off mesh, if it's not another data product reading from it, to a particular user, to a particular request, to a particular use case. If I would go in and I have permissions to access the Databricks directly, I think you asked Snowflake, right? To access the Snowflake directly underneath, I can do that. As of the status quo right now, we wouldn't capture that usage because it's happening even without context, right? We wouldn't know why has that person accessed or what is the credentials of that particular user account. So we have some thoughts like later down on our roadmap to grab that as well and just accumulate this additional access. As of right now, just to also get all the context around it, we would recommend to request access throughout those APIs, simply because it actually allows the insights to be meaningful rather than just some anonymous access down there.
Awesome. Well, we are at time. Thank you so much, everyone, for the questions, everyone who joined. I'll send out a follow-up email with the resources that Jörg mentioned during the webinar, as well as a link to the recording. And feel free to send any additional questions our way. Perhaps I can kind of put a digest together of all the questions that were asked and the answers for them. But yeah, thank you all so much. Jörg, any final words?
No, as said, there are also some. I think you're also going to share like the speaker notes, right? There are some more links to blog post and additional information around.
Yes, definitely. Um, well, great. I hope everyone has a great rest of their Thursday. And yeah, hope to see you all soon.